Hi, I'm Kevin Van,
And I'm Eric Yoon.
and we're from Johns Creek High School. Today, we're excited to present Segmental, a foundation model driven system we've built to accelerate clinical image segmentation and analysis, making advanced medical AI accessible to everyone.
In the world of medical diagnostics, speed and accuracy are everything. Yet, a significant bottleneck exists. Manual segmentation, the process of outlining anatomical structures on scans, is incredibly time consuming. As one study on prostate MRIs found, a single segmentation can take a radiologist an average of 11 minutes, making it prohibitive for real time application.
Beyond individual analysis, creating the high quality labeled datasets needed to train new AI models is a monumental task. One study showed that annotating a large dataset required over 24 man days of work.
Finally, the entire process is fragmented. Clinicians often have to use one tool for segmentation and another for analysis, introducing delays and potential errors. These challenges slow down patient care, hinder research, and create a need for a unified, efficient solution.
Our solution is Segmental. We've built an integrated platform that addresses these challenges head on. At its core, we use MedSim, a powerful foundation model from Meta to provide instant and precise image segmentation. We support interactive prompting with bounded boxes to give users full control.
Crucially, we integrate Google's Gemini Flash, allowing for immediate AI based medical interpretation directly within the application. This is all wrapped in an intuitive graphical user interface built with PyQt5 that supports all major medical image formats, including DICOM, PNG, and JPEG.
The benefits of this integrated approach are clear. Segmental allows for entire dataset uploads, drastically improving efficiency for large workloads. By integrating a mainstream AI model like Gemini, we create a fluid, all in one workflow, eliminating the need to switch between different applications.
Our application is also lightweight, designed to run on standard consumer hardware without intensive resource demands. And most importantly, Segmental is open source. This makes it easily accessible to the public, encouraging further development and making advanced medical AI a practical tool for any clinic, lab, or student.
To build this, we leveraged a robust stack of modern technologies. We used PyTorch and NVIDIA CUDA for high performance AI inference, Google's Gemini API for analysis, and libraries like OpenCV and PyDICOM for image processing. The entire application was developed using tools like PyQt, Git, and Visual Studio Code to ensure stability and compatibility.
The magic behind our instance segmentation is the SAM pipeline. The model takes an image and a user provided prompt, in our case, a bounding box, and feeds them into a series of encoders. The image encoder creates a deep feature representation of the entire scan, while the prompt encoder specifies the exact region of interest. These are then combined into a mask decoder to output a pixel perfect segmentation mask, all in a fraction of a second.
The bounding box is our primary method of interaction. It's an intuitive way for a user to quickly tell the AI which area to focus on. By simply drawing a box, they provide the model with the necessary context to generate a highly accurate segmentation, whether it's a small lesion or an entire organ.
Segmental is more than just an analysis tool, it's a creation tool. One of our key features is the ability to load and manage entire datasets. Users can quickly cycle through images, generate masks, and export them. This dramatically accelerates the process of creating labeled datasets, which is a critical step for training the next generation of specialized AI models. It turns a task that once took days into one that takes hours.
And here is where our platform truly becomes a unified solution. After generating a mask, the user can click Analyze with segmentation. Our system sends the image and the mask to the Gemini API, which returns a detailed, structured analysis. As you can see here, it provides the image type, anatomical region, and a detailed analysis of the segmented area, pointing out normal versus abnormal appearances. This integrates the what with the why, all in one window. And now for our live demonstration.
Okay, so here's our app, Segmental. On the left, we have a sidebar with some functions. In the middle is where we're going to view images. And on the right, we have messages of system status and analysis results from segmentation. I'm going to start off by loading an image. I'm going to go ahead and load image number 2. The image is first going to go through a surface level analysis so the model understands what the image is. Now that the image has loaded, we can go ahead and draw a bounded box. This restricts the model to specifically view what is in the box and create a mask for the important components. As you can see here, the model created an orange mask. We can go ahead and create a few more. If we want to create a precise bounded box, we can go ahead and zoom in. Or if we want to create a broad bounded box, we can go ahead and zoom out. Okay, and if the user made a mask accidentally, say like that, and they want to delete it, we can go ahead and undo mask. Or if they accidentally deleted one that they actually wanted to keep, we can go ahead and redo it. So now that we have masked the areas we want to focus on, we can proceed with the AI analysis. The user can press API configuration and input their very own API key to choose which AI model they want to use. So we have preloaded the API key already, so we can go ahead and just save and press analyze with segmentation. As we can see in system status over here, the image is being analyzed by Gemini. What happens is that we upload the image and the masks to Gemini AI, which is going to scan the image and the masks and access the near infinite knowledge of the internet to give us a well-documented description of what we're looking at. We have tweaked the AI to only use reliable sources and focus specifically on medical aspects. So Gemini AI has returned its reply, and we can see that it has identified what the image is, where it is found, what's wrong with it, some physical characteristics, and what the logical next steps are. Now, for our most important feature, which is loading databases. So by clicking on loading database, we can go ahead and load a folder of images. By clicking on browse database, we can browse between the images in the folder. We can draw masks on the images, just like that, and send them to Gemini individually, or we can send the entire batch for a more thorough analysis. This is Segmental.
Here are our sources.
Our work stands on the shoulders of giants. We'd like to acknowledge the research behind the MedSam and SAM models, the public datasets that enabled our testing, and the open source community that builds the tools we use every day. We would like to thank the incredible teams at Meta and Bo Wang's lab and the public dataset owners for providing these models to the medical imaging community and inspiring this project. Thank you.